Hey everyone, thanks for coming. This session is probably one of the most exciting for me of the year. Web is one of those sort of main focal areas at the moment. I spent a good amount of my placement here doing that, so really excited to go through this session with you today. So I realised I'm not the slide deck. I have a designated slide deck. Just a little thing before we get too much into it. We are partnered with the IT Society at the university. Straight after this, IT Society are running lightning talks. If you guys haven't been to lightning talks before, they're quick fire talks from staff and students. Have you got
Richard Nadine is speaking.
3 staff today, isn't it?
I don't know if it's Richard Nadine, and
Nadine's
one or two others.
Yeah, Nadine's ill. It's free.
Oh, okay, then he's not coming then. I'm the event set, but our president has done all of this, so
it's 3 speakers plus potentially Brandon. I think you say Brandon doing something more.
There's a bit about talks.
there's food.
There's food as well. We have free pizza here, but they've got more free pizza as well. So I know this is your lunch, that can be your dinner. Lightning talks are really fantastic. Sort of gives you more info outside your course and more time like this. They'll be in Portland 1.11 after this. Definitely suggest going along because they are pretty fantastic. Cool. Today, I don't know, sort of quick show of hands, who's touched the web at all? From a programming angle, not just like necessarily coding. Doesn't matter. Today we're going to go all the way back in time to when the web first started. And by the end of the session, every single one of you is going to have a website posted on the internet for all to see. That's the plan. We're going to see how we get there. We're also going to have a bit of talk about the modern web, some things that are changing, because the web is one of those things that purely because of the scale of it and how open it is, the web is very much always changing. Lovely. So like I said, we're going to split it into 2 halves. The first one is mainly talking about the history of the web and where we are now, called spinning a web. The second half, Incy Wincy Spider. We're going to be making some websites, getting them posted on the internet, which will be pretty cool if you say so myself. So, start with history. Does anyone know what year is going to appear on the left-hand side? Any guesses? When did the web start?
It's like 1960 something, isn't it?
Any updates on 50s? What's that?
So I thought it was like just about the 60s.
Just about the 60s? 14?
Yesterday.
Website yesterday? Any others? Alright, fair enough. So in 1989, the web's actually fairly recent. In 1989, go next slide, there. A chap called Tim Berners-Lee, you might have heard of, proposed 3 things: the World Wide Web, HTML, and hypertext protocol. Split them into 3. These are sort of the 3 things that enable the web to exist. Tim Berners-Lee was a researcher at CERN in the time. They wanted a way of communicating files between each other and accessing pages on their computer devices. First thing that existed was WW, or the World Wide Web. This was the first ever web browser. It enabled you to visit a path, a URL, and view that page on your browser. How does that actually work? First up, you need some sort of form to your page, some sort of overall structure. And this hasn't really changed much since 1989. So HTML, hypertext markup language, was the overall form for a website, even back 30 years ago when the web first began. And you can see this code is actually straight from the first ever website. The first ever website is still live today at info.cern.ch. If you go back to your browser, you can genuinely still view the first ever website that was made. So I think that's pretty neat. But you've got this sort of static form. We need to be able to get this form to other people's computers, otherwise the web is a little bit pointless. And that's where hypertext transfer protocol came in. And this was a one-line, very small way of transmitting files and requesting them. So it consists of 2 parts, and for some of you that have done web programming or working with an API before, which is something similar, consists of a verb, so usually get, put, delete, some others, but back then, get and just the path of the thing you wanted to get. All of them are .html files we mentioned. So you're able just to, in this small bit of code, to tell a server, hey, I want this file. From sort of a visual perspective, as if you've got your browser on the left, server on the right. Your browser goes to the server and says, hey, I would really like my page. In your browser, that'd be whatever website / my page. And the server goes, hey, yeah, I don't know what this means. And it will literally give you the HTML code as plain text for your browser then to render. The key bit there is that your browser is the rendering engine. A lot of other languages might render things to the screen themselves, but HTML says this is the thing and lets your browser handle everything else. That comes important later on, and you may even notice as you go through web development, different browsers handle things differently. But back then it was just one browser. Life was fairly simple. So what I said, all these three technologies existed at CERN, but they kind of need to get out to the rest of the world. So sort of around 91, the first web server came out in the US. So CERN's in Europe. Now the web has grown to the US, and pages are starting to be hosted over in the States. That was a fairly big step, but not as big as the world of web becoming open source. So the code for how the browser worked was now publicly available. And it meant that anyone could make their own browser if they wanted to. And everyone had a sort of free reign to really do whatever they wanted with the web. As some of us know, that's sometimes a fantastic idea. Sometimes using the web however you want is a less fantastic idea. But to try and make sure that everyone's version of the web was talking to each other, Berners-Lee left CERN and joined MIT over in the States, and founded what's known as the World Wide Web Consortium, or W3C. This still exists today, but basically that was a standards body for the web. It said if you want to handle HTML, probably do it like this, and lots of other small bits of standards that allowed people in the US to be working with the same as people in the EU. Again, it's a worldwide web. Standards are important in making sure that everyone's working in similar ways and everything's compatible, interoperable, all of those different things. In 1994, a company called Netscape, if you're a software engineering student, that company should be familiar to you. Netscape was a small company. Started off as a company called Mosaic. However, there was a company that was also called Mosaic, they had a bit of an issue, rebranded to Netscape. Netscape were interested in the web, they found it quite interesting, and they decided to make their own browser. The browser was a big success, it was called Netscape Navigator and looked like this. It doesn't look too unfamiliar, right? You can generally see that. If I showed that to you without a precursor, you go, that's a browser. As much as the web's evolved, these sort of core principles have stuck around, right? You've got form, HTML, you've got a way of talking to each other, you've got the browser. Everything's kind of there, but Netscape was a huge success. And sort of when the web really started to explode. Shortly after, there was a chap working with Netscape called Brendan Ike. In 95, he was working on a small server-side language called JavaScript. Well, at the time it was called LiveScript. But then in a last-minute marketing decision that's played us ever since, they looked at what some were doing, some microsystems, and they said, hey, Java's really popular. LiveScript's not going to sell very well. Let's rename to JavaScript, even though it's nothing like Java. So that marketing decision has played us ever since, but alas, it's called JavaScript, and released alongside version 2.0 of the browser, which allowed us to have functional websites, right? We're not talking about static forms anymore. Things can change, things can evolve on the web page. That allowed us to do a lot more. Shortly after the first standard for CSS, or cascading style sheets, was published. CSS is an interesting one. It's a very simple style sheet language that allows you to define how things look. It's different from HTML that says semantically, this is a header, this is a footer, this is a body, this is a link. CSS does the opposite, and it says how things look. It's also very readable, as you can see by this slide. You can read this and you roughly know what's going on, right? Every body tag on this page has a salmon background, which is a beautiful, lovely color. Every paragraph is in green text. Every list element that's inside the paragraph is blue. This page would look horrific, but it makes it very easy for us to make make pages look like what they should look like. This motion steps are right around. So with that, and CSS is still around today, still evolving through standard bodies. But again, fundamental component of the web, existed for many years now, and still exists today. So that's 96, that's already, what, 7, 8 years progress. Shortly after, other companies saw TypeScript, JavaScript, and they said, I want that for my browser. And people started working on other versions of JavaScript for their browser. Microsoft worked on something called JScript, which worked on Internet Explorer to implement something close to JavaScript. But there were still discrepancies on how JavaScript should work, where were its limitations, and really what it should look like. So Netscape talked to a European standards body called Ecma, Ecma International. They already existed, and they were doing other standards. They wanted to make their version of JavaScript the standard. So it says variables should behave like this. This is how a for loop should be structured, even small semantics like that. And again, similar to how we have these standards on the web consortium, JavaScript also being a standard allows the web to be open, but still interoperable and work with each other. So Netscape working on the background, and shortly after, Ecmascript 1, which is the real name for JavaScript. Ecmascript is the standard, but everyone just calls it JavaScript. But whenever you're talking about JavaScript today, you're probably talking about Ecmascript. Ecmascript version 1 released, you might get 7-ish. Then it runs to 99, they're fairly active on the browser. So Ecmascript kind of carried on evolving. The HTTP standard we talked about earlier, that one line, I want this page, please give it to me, that also continued to evolve. And even today we're on version 2.0. 1.1 came out, gave a lot more information about the files that were being handled, and allowed us to do more complex things on the web. But like I said, Ecmascript continued evolving, Ecmascript 1, Ecmascript 2, Ecmascript 3, so we have some more complex language features. And Ecmascript 3 was fairly stable, had a good feature set, but in the background they started working on JavaScript 2.0. They thought the web is getting big. We should do something about it. We should make JavaScript this nice, large, stable language, lots of complex features. We think it should behave like this. I think the next slide, if I remember correctly. This page is on the web archives, and it comes straight from Netscape. Developers there set out, they said, these are the goals of JavaScript 2.0, and these are not the goals of 2.0. So you can see on here, we want the language to be suitable for modular and object-oriented. JavaScript isn't object-oriented. It's a dynamic programming language, mainly just a scripting language for small things. Object-oriented is good because Java said so. Bit tongue-in-cheek, but not horribly false. We want to make it possible for applications to be robust but also secure. You can see they kind of good amount of set of goals. They said JavaScript is not currently a good general purpose language. It works fast, but we want these to be stronger, better, etc. Netscape weren't actually the first people to look at this and start implementing it. These guys were. This started an interesting point in the web. So Microsoft looked at this standard, this idea of JavaScript 2.0, and they started implementing their own features. They'd been working on Microsoft.NET at the time, which was this other platforms and other programming languages. It was largely successful and still is today. But they wanted to combine their work on JScript, their flavor of JavaScript, and their work on .NET to make JScript.NET the next big thing for the web. It was going to be a great idea, it was going to do lots of different things. And they released it. They attempted to follow the work of Ecmascript 3, that's just been released through the Ecmascript body and Netscape. And it roughly followed the standard. At the same time, so this is JScript, you could run it in your terminal, that was a big improvement. It wasn't just a browser anymore. You could do lots of different things, and it was compiled as well. So you can compile language from JavaScript, you can use write a terminal, fairly useful. At the same time, a company called Macromedia made this thing. This thing's called Flash. It used to exist, doesn't exist anymore. But at the time, Flash was a big thing. They made their own programming language to go with Flash. Flash being this nice interactive language, we can make games on the web, other stuff. ActionScript was kind of like JavaScript in terms of its syntax, its overall structure. It did have a few differences. So, in the meantime, when all these companies were busy doing their own thing, the idea of Ecmascript 4 and JavaScript 2.0, kind of the same thing-ish, were all going around in the background, but eventually it came to a bit of a halt. So, within the Ecmascript sort of background, we had this sort of like dark age, where not much happened and no progress was made. By that, I mean Ecmascript 4 was abandoned. A lot of people on the Ecmascript committee started disagreeing with each other. Obviously, you had the likes of JScript from the Microsoft folks going, JavaScript should do this. Netscape folks said, hey, JavaScript should do like this, get away, we made it. There was a lot of disagreements over some fairly small and fairly large things. They tried to make JavaScript object-oriented, which is a big step. Other people said it shouldn't be done. Even people from ActionScript were getting involved. It was a bit of chaos. So during this time, a few big things happened. Netscape Navigator died. Internet Explorer came out. Internet Explorer was a huge success. Obviously, everyone's favorite web browser. Internet Explorer still exists today. Largely, kind of being part of Microsoft Edge. So that completely destroyed Netscape. Firefox also released a company called Mozilla, putting their feet into the web world. And also, Adobe bought out Macromedia. So Adobe now owns Flash. So you've got some big players in the web world, right? You've got Microsoft, Netscape was more like Mozilla are here. There was a lot of players, so Flash are involved. You also got Yahoo. Yahoo were getting involved in the web at this time. A lot was going on, there was a lot of disagreements. We tried to work together to make another version of Ecmascript, but that didn't really work. So again, we had a lot of innovation on this hand side, and now we're disagreeing on things and nothing's really happening on the web anymore. Will the Ecmascript committee exactly? A lot of people, particularly on the Microsoft side, wanted to make this like a big legal committee. They wanted a paper trail on everything. They wanted grievance procedures if there were disagreements with the committee. It was chaos. Most people just wanted to disagree on technical stuff. There was a bit of disagreement on the legal side as well. But largely people went, screw the legal stuff, let's do the technical stuff. And so, people eventually realized, hey, it's been 10 years now. We're in 2009 at this point, very late 2009. We need to make something. So they put all the good bits from the languages they could agree on, and they made Ecmascript 5. They were originally going to call it 4.1, but that still implies that there's going to be, I don't think they're going to call it like 4, yeah, 4.1 to start with, but then they implied that 4 was still going to happen. So screw it, we'll call it Ecmascript 5. And this Ecmascript team, that committee, is disagreeing with each other. In their exact words, they agreed on harmony as their development methodology. Whatever harmony means, still don't know. But they agreed, we're going to work harmoniously together. Which sounds fantastic, but it worked. Ecmascript 5 released, following year. Ecmascript 5.1 released, I'm not following year, 2 years later, I was slightly off. Then shortly after that, we had Ecmascript 2015, because developers are good at versioning things. After that, we had Ecmascript 2016, Ecmascript 2017, Ecmascript 2018, kind of get the picture, we're using this version now. It's been happening every single year. Some really good improvements coming out to Ecmascript, JavaScript. It's evolving well. The web's kind of in a good place when it comes to JavaScript now. It's a language that's booming in terms of popularity. So despite this sort of dark age and this 10 years of progress before it, like 10 years of a good amount of progress, despite a sort of middle shortcoming. That's mainly JavaScript. However, JavaScript still sort of existed in the browser. Everyone's browser was doing different things. One of the people that wanted to get involved was Google. Google made a browser called Chrome at the start of 2009. And with that, they shipped something called the V8 engine. Apparently, it's named after the car engine as well. They're trying to be witty. I don't know. I don't know where V1 was, but we're here. V8 engine really said, this is a good way to write JavaScript. You can plug the V8 engine into a browser. You can plug it into other applications. And it became like a relative standard for doing JavaScript development and using it as a runtime. One of the people that thought this was a good idea took the V8 engine, strapped a package manager onto it, and allowed it to run server-side. I did say, right back at the beginning, when JavaScript was first being worked on in Netscape, it was a server-side language. Then it turned into a client-side language, and then it went, let's do nodes, we can allow JavaScript to run the server again. Node.js, for those interested, allows you to run JavaScript on a server. That's a direct quote. It's JavaScript runtime built on Chrome's V8 JavaScript engine, so the JavaScript running on Chrome can now run on servers. Other big words to go with that, it's asynchronous. You can do a task, and because JavaScript only runs on one core, can't do multiple tasks at the same time. So let's wait, do something else, but then realize this is now done and come back to it. That's what asynchronous means. Event-driven, similar things says when the browser does this, we can wait and we can do this. So if we're waiting for an on-click or listening to the on-click event, whenever there's a click, we can do things. Like I said, single-threaded, we can't do too many things at the same time because it's JavaScript, but it gets the concept there, and Node is still wildly popular. This is what Node looks like. This is actually relatively straightforward. It allows you to run a server, and if you put this code on your computer now, this would run a server from your local machine. This is all stuff that's built into Node. You can read it pretty top down to bottom. We have a create server. Whenever we create our server, we say 200, it's a success. HTTP has lots of these stats codes built in. There's things like 200, which means it's a success. There's error codes like I'm a teapot. All these codes go in, 404, obviously you might have heard of that one. Content type tells you what kind of content we get out of the server, and then we end our response and we ship it to the user. This server.listen basically says forever, I want to be able to go to this in my browser and be able to access the web page. As part of Node, I mentioned they shipped a package manager. Does anyone roughly know what a package manager is? No, that's fine. Basically, I've got code. My code's great to me. But you might want to use my code. There's no point doing the same thing over and over again. There's no point writing a server engine multiple times. Let's just use someone's server engine so that I can go make my web game. And that's where the idea of a package manager comes in. Projects typically have versions. So my 1.0 might be okay, my 2.0 might be better, my 2.1.1 might have a small security fix. But having a package manager allows you to not only install the latest version of packages, but also to make sure that everyone else is using those versions, and generally distribute packages on the web. It's all fairly straightforward. Those three simple commands will set up a project on your local machine, on your server, and install two packages. One of them is written by me, the other one is just a largely popular one for servers. But the fact that me, as just some random person on the internet, can go and make a package and ship it for everyone to use for free. It's one of the core advantages of the web. I think it's one of the things that makes the web extremely popular. Packages like Express are just monolithic piece, lots of contributors, lots of people, again, fighting over the way things should be done. But it's allowed for a lot of innovation on the web. If you go to the next slide, web is massive compared to everything else. So this red line at the top that's taking a very steep climb is the number of modules published on NPM. That's each individual package that someone has made and released. This count is about 700,000, and this was from 2018 and 2019. When I wrote these slides about a week ago, There's now 1.7 million packages. So they've done like a cool another million in the last 3 years since this was taken. The web is booming, there's loads of modules. And if you compare this to other things, so what we've got on here, some of the Python stuff is on here, that's way down here. We've got Java. Maven was actually fairly big. It was a way for putting packages from Java into your project. NPM just skyrocketed. Largely due to the open nature of the web, a lot of the JavaScript work, it just took off. So that's Node. Next up, sort of looking together. We've got a form, we've got style, we've got a function. That's great, we can make more pages, and we can run it on servers. So not only can browsers request things from servers, our server can now talk to a database. Our server can do cool logic that we don't really want the user to see. Maybe the user's got a really terrible computer, terrible phone, offload some of that work on the server. This sort of core ecosystem makes up a large portion of the web. The top three you basically can't go without. Node you can go without. You can just upload HTML files somewhere on the internet, someone can use them in their browser. It's quite nice. But the web, in terms of sort of core fundamental principles, like here. And that's pretty neat. Next slide. So that's the core stuff out of the way. People are never happy with just core stuff. Microsoft wants to jump back in, do more flavors of JavaScript. So whilst JavaScript runs in the browser, a lot of people have released flavors of JavaScript that work in slightly different ways, have different improvements, but they'll compile back down to JavaScript so they can run in the browser. JavaScript, for those of you that haven't used it, isn't a strongly typed language. What I mean by that, whenever you have a function, let's say add, if we're adding A and B, we're not forcing A and B to have different numbers. So we could be adding strings together, we can't stop our users from doing that. TypeScript really wants to add some control, some safety, so it allows optional typing. Go to the next slide. On the left-hand side, we have some JavaScript code. On the right-hand side, we have some TypeScript code. So a few observations. TypeScript is longer. There is more code to be written. JavaScript is shorter. Both of these two things do the same thing. They take in an object. I am an object. I have a name of the page, and I would like that info to be printed out to the user. Both of these do those two things, but differently. On the left-hand side, there's no concept of that object. The object is just something that I've thrown together. I said there is a Michael. Michael is an object. Michael has the name Michael, and Michael is 21. And my function just takes in some concept of a person, some variable, assumes that name and age are a part of that person, and console.logs it. That's similar to print in other languages, pretty straightforward. On the right-hand side, TypeScript's given us a bit of safety here. Michael is a person. What's a person? A person is an object with a string name and a number age. So you can already see there's a bit more safety there. I've had to write more code, and that is a trade-off from TypeScript. But we have more safety in the things we do. For our function, we specify the person is of type person. We know that we're going to get a name and an age. Where on this side, if I said person is 43, well, 43 doesn't have a name and an age anymore, and that code will crash. TypeScript wouldn't allow it to crash. And also the developer experience on TypeScript is pretty top-notch. Because we know it's a person, whenever we're typing in our editor, and we do person dot, it will automatically suggest that it has a name. It will suggest that it has an age. Whereas on the JavaScript side, you kind of just have to assume that. We have to look at documentation, and ain't nobody got time for that. TypeScript's a lot safer, you have to write more code, but the developer experience is nicer. That's kind of the trade-off there. Go back to previous point. My previous point, next slide. TypeScript sits around JavaScript. This is a Venn diagram, believe it or not. I was clever when I used their logo as squares. JavaScript on the inside doesn't change. It has all the core features of JavaScript, things like const and let, which are the two ways to define a variable. Ignore var, don't have to use var. Const, variable is not going to change. Let, a variable might change. Functions, for loops, while loops, you have a lambda function. You can look at that your own time. But those concepts are within JavaScript. all valid JavaScript is valid TypeScript. That's a core advantage of TypeScript, because it means it can be adopted incrementally. So on placement, when I started placement, they were all writing JavaScript code, and we said, this isn't working for us anymore. Let's slowly adopt TypeScript. We can rename all our JavaScript files from .js to .ts, and it will work. And then we can slowly add some optional features like types, interfaces, which I just showed you, and it has sort of person attributes and that sort of thing. But TypeScript, because it compiles back down to JavaScript, detects those errors when you write your code, rather than waiting for the user to touch your code and it break. So it kind of shows the point in where some errors are found, and ideally you want your developers to find the error, not your customer, especially if they're paying for your product. Besides that, it causes stress and other bad things that we don't want people to go through. So TypeScript goes straight down to JavaScript in one command. You can configure some optional features. Like I said, TypeScript is fully optional. But if you want to force other features onto the developer to make their experience better, if not, have to write the code. TypeScript compiler will allow you to do that. And then one other thing I did want to mention. A group of developers working on a small social network called Facebook decided that a lot of stuff they were doing with the web was okay, but they were having a lot of difficulty manipulating elements. They were having difficulty displaying certain things on the screen. The amount of code required to do that is actually fairly lengthy. You have to grab an element, you've got to put some content into the element in the right way that it doesn't break. JavaScript's not giving you much support there. So let's see if we can do something better about it. We released this language called React, and it's what still powers Facebook today. Go to the next slide. This is an example of some React code. It's still written in JavaScript, although you can write TypeScript React and it works quite nicely together, in my opinion. At the top, we're grabbing the React language from NPM, our package manager. We're making a sort of hello world component, which this looks like HTML, and that's because it is. In vanilla JavaScript, you can't just write some HTML in. That's for your HTML files. React sort of blends the two. Critics of React will say it blends the form and function attributes, which typically are kept separate, and makes them the same thing. But that's also the whole point. This is the old way to write React, and it's the way they first started. I'll show you a better way to write React in a little bit. You can read this code. It grabs the name attribute from here. And on the page, you will display a div, which is kind of just an empty container. And it will say, hello, GDSC UoP. Whereas the JavaScript code of this would be actually fairly lengthy. And I mentioned that TypeScript and React work well together. Got an example of that coming up. But I should also note that React can't just run in the browser. I said HTML variables in code doesn't look good. JavaScript needs to handle that somehow. And so React does compile now to JavaScript as well. Here's the next slide real quick. That small bit of code up there compiles to all of this nonsense. And this is how React was first written, when they were first trying to put it together. But that top left is so much cleaner, so much nicer to write. These actually have different file extensions, even though they're the same language. So React files are typically .jsx or .tsx if you do TypeScript. Whereas this is the stuff that your browser gets. You never have to see this, you never have to deal with this because it looks ugly. You just React.create element div, some attributes to pass in, and inside that there's a span and some children. That's nonsense, this just writes HTML. You should also note that one of the side effects of React is we need this code to render. In order to do that, React ships its entire library called the virtual DOM, DOM being the document object markup, I think, that actually allows HTML to be manipulated, but it ships this virtual DOM that allows React to sit on top of it and behave nicely. That means you're shipping more code to the user. If you're on a slow machine, they've got to download all that code. But it is a trade-off with React, and React is by far the most popular front-end framework. There are others, we'll get onto those, but that's the kind of rough idea. Front-end frameworks. There is a joke amongst web developers that every single week there is a new front-end framework. Not really a joke, it's fairly true. Whenever you're deciding on a project, you need to decide what front-end framework you use, or none of them, HTML, CSS, JavaScript, very valid way to make a website. But you can do other things, and especially in the industry, just doing HTML, HTML, CSS, and JavaScript isn't really cutting it anymore. We have other things like React that makes things a lot more maintainable. Instead of having to write the header in every HTML file, you can just write the header once and drag it in. Looking at front-end frameworks, there are a few. This is taken from the State of JS survey. So every single year there is a survey sent out to JavaScript developers, and as a community we can all contribute to this. We can say what do we like in terms of front-end frameworks, what do we like about JavaScript itself, how do we style our websites, do we use any external libraries? But one output of that they produce every year, and I absolutely love this graph, is how often have we used the language, and what do we think of it? Like, do we like this? Do we hate this? So React, I mentioned, one of the most used front-end frameworks. It came out, one of the first front-end frameworks. And it really just skyrocketed. Everyone's been using it ever since. It's likely that if you go for a full stack or a front-end job as a web developer, you're probably going to touch React. A few of you might go, Michael, this is a Google presentation. Google did make a front-end framework. It's called Angular. It's in the negative opinion side and it belongs there. That's all I'll say on that. Some people still use Angular, still exists, but Google have officially deprecated it. So most people use things on this side. Vue also exists. Vue is a valid option. More people use React and it overall has more positive opinions, so I wouldn't bother touching that. React is an interesting one. I mentioned that React ships all these complex features to your browser, which takes a lot of files, takes more time than page load. React is so small that it can run in a banner ad at the side of the page. That's the idea. And in terms of code, it's the same as React code, you just can't use the advanced features. Oh no, not many people use the advanced features. Anyway, React's pretty new. Ember I've not really touched, but no one likes it, no one's used it, so we're not going to. Svelte. Svelte is an incredibly interesting language. You can see already it's at the positive opinion side. If you go to stateofjs.com/2020, I'll link it in Discord at some point. Svelte is doing this. More people are starting to use it, and everyone really likes Svelte. A lot of money on Svelte recently. The creator of Svelte has been bought out by the company named Next.js, which are a big backend framework, which we'll get onto. There is money going into Svelte. It's really nice to use, and I actually encourage you guys to do the tutorial for Svelte on your browser sometime. It's actually quite nice to work with. It's a fun front-end framework. React sometimes isn't too fun. And in recent surveys, this trend line is starting to do that. It started to curve towards negative, more people using it. You get fed up with it. Svelte's new, it's shiny, and it's actually quite nice to write. You have to write less code to do several things, which is one of the advantages. Cool. Having said that, Svelte, this is the most recent survey, and I've linked it down there. 2020 got state of JS, I wasn't too far off. Svelte is at the top of the satisfaction ratings. So even though not many people are using it, people find that Svelte is the most satisfying front-end framework to use. Narrowly above React. I mentioned Angular. This is my point in data, don't use Angular. Because it's Svelte, despite being very small, relatively new front-end framework, it's skyrocketing. They say that React is still used more in industry, so probably if you're looking for what you should learn to get a job, React right now seems like a good option, not forgetting the fundamentals in HTML, CSS, and JS. Again, I think my slides are slightly out of order. TypeScript and React, it looks like this. It's cleaner, has the safety of TypeScript, but the benefits that React brings. That's like far out of order there. You get the picture. And that's where history is right now. There's some really interesting concepts coming up in the web. I think the next slide touches on this. But it does touch on. This is where the web started, and this is sort of 32 years in the making. We've still got our core concepts, they're not going anywhere. So definitely get your fundamentals in HTML, CSS, and JavaScript before touching anything else. But realistically, the web's in a good place now. Unless history is going to slowly repeat itself and we have 10 years on, 10 years off, which is not looking likely, we're in a good place. The web, even though I'm not much of a history person, I find this stuff fascinating. Just how an open language can be affected by people, the way people decide to use it, All this stuff for me is just incredibly fascinating, and I will happily have conversations about this for days. But with that said, history is one thing. Cool story for it. How to make websites that people actually visit. It's a great question. Next up. I showed you guys this slide 3 weeks ago, now it's consolidation week. In the old days, and still now, your client, your browser will talk to some server, which will talk to some other server, some database, a CMS, which remember I said is a database with a pretty front end on it so that non-techies can use it. This is kind of how it works. You do your request in between. We talked about GET requests. I mentioned put and update and delete and those sort of things. The web's evolving, and this is typically what you're dealing with. I've not got time to go into too much depth on those. But at the software level, we also talked about serverless. Serverless is free usually. It starts off there, and you only pay for what you use. This came about because of the cloud, where your browser automatically just grab pages from a CDN. Think of it much like you think about Google Drive or Dropbox. You just shove files there, and people can access them using GET requests. These other microservices, they don't sit on our server anymore. We go pay someone to deal with all for us because I'm not writing all code. You go pay for a database service, or you can get a free database service such as Firebase. Functions as service, some of the code would run on the server. Just grab this function and host this function for me. But this is free, this is cheap. And it's a good way to write servers, it's a lot faster as well. But like I said, the simplest way you can make a website and host on the web is to write some HTML, some CSS, JavaScript, your form, your style, your function, upload it to some form of storage, or host on a server, Node is a good option. And then from there you can just keep over-engineering stuff endlessly. That's the web developer lifecycle. That's very simple, and that requires manual effort. Continuous integration comes in. Whenever I push code to GitHub, I would like it to end up on my server, and I don't want to have to do that myself. We're going to talk about a practical example of continuous integration in a few minutes. The basic idea here is DevOps, developer operations. We automate any of the boring operational stuff of development. Just let the computer do it for us. I don't want to deal with it, so whenever I upload code, it should end up on my server automatically. Unless there's issues, then it should prompt me and I should solve them. This looks bigger. I'm going to go through this in a bit. Specifically for Firebase, they offer a Firebase Hosting thing that allows you to upload those static files or those compiled files if you're using React or TypeScript. In a name, you're uploading HTML, CSS, JavaScript, maybe some images, I don't know. And it happens all for you. You're storing your code on GitHub or other things. GitHub Actions is a good way of doing CI, again, Firebase out in a bit. And then within Firebase, you can create these applications for free. Unless you start doing extreme stuff with it, but for our purposes, it's more than enough. Then we just push it all to GitHub. We add some keys. Keys are important. Keys are secret. You shouldn't be giving people your password. Don't give them the secret keys. Secret keys will allow the user to upload stuff to your server, which they would allow people to run your functions and practically DDoSing your bank account as people just use your stuff more and more and more and more outside of normal bounds. Not a great idea to leave keys lying around. So that's why they end up in your repository secrets. There's a configuration file you can use, we'll hit that in a second. When you just push the files to GitHub, it ends up on the web. Easy, profit. Next up. We're going to skip the live demo because screen sharing did not work. I said a lot of words. I joked that a new web framework comes out every week. It does. There's a lot of things you can use. And to make a website, you can genuinely pick something out of each bucket, maybe a few different things, and then you'd have an over-engineered website, but it'd be pretty good. So you have front-end frameworks like React, Angular, Svelte, that allow you to make these components, do stuff with these components in a way outside of HTML and JS. Usually you have to write less code to do it. That's the key advantage. I mentioned JavaScript flavors. There's other ones that aren't TypeScript. You can just write down JavaScript. In terms of data layer, which is usually the stuff between the server and the client, how are you passing data between each other? RESTful is usually the main way people go, so that's things like get and put we mentioned earlier. And then there's like a 20% audience that use something up and coming called GraphQL. Do some research in the your own time, it's actually pretty interesting, definitely has a use case. Or the back-end framework. Well, we've got a front-end framework. Maybe I want to do my setup at the same time. Next.js, for example, we're going to use that today. Testing. No developer likes writing tests, but no user likes bad products, so it's kind of a trade-off. There's testing libraries for allow your individual functions to be tested. Those are things like Jest or Storybook is a good one for testing React components and displaying them in a nice pretty format. There's also things like Cypress and Enzyme's not on here, but for example, that allow end-to-end testing. So your code will automatically open your browser, click on a button, and you'll get the expected output. That's the stuff that's often overlooked. But if you do that and you're capable of doing that sort of thing, your product will be better, your user will have a better experience, you're more hireable, etc. It's a good advantage to do testing. Build tools. I mentioned that TypeScript and React and those sort of things need to be compiled back down to HTML, CSS, and JavaScript. Build tools that you do that. There's a lot. TypeScript itself has a compiler. You can use that. That's a lot. Filter down a little bit. If you want to learn anything, those are my personal recommendations. Both from this is what industry uses, a little bit of personal opinion in there. TypeScript is a good thing to learn after you've learned JavaScript. And if you want to use a build tool, you should use TypeScript if you're going to use TypeScript anyway. If not, the other ones are on there. The state.js survey is a good one to identify exactly what tools you should be using. Testing, you'll notice there's a few highlighted, they do different things. Pick one out, try it. Well, that's the general idea. Once you've done that, and that stuff that we just saw is already beyond those core web components. You can go beyond the core web. Writing CSS is terrible, I hate it. You could use something like Tailwind CSS. Anyone use Tailwind out of interest? Nice. Rather than writing this color should be this, blah, 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 you can do that in a much more descriptive way, in utility form. I quite like it. It's fairly polarizing, but it's actually getting increasingly popular. Electron, who uses Discord. Discord, written in JavaScript and web technologies, and then is powered on Electron to allow it to run on your phone, your desktop, etc. Electron's fairly funky, but it works. Material UI is a framework for React that allows you to import pretty looking buttons and that sort of thing. And then a really up-and-coming topic I've just not had the time to go into is WebAssembly. Previously, you could just run JavaScript in your browser. JavaScript has limitations. Or you could run other languages. WebAssembly kind of bridges that gap a little bit. So there's up-and-coming languages like Rust. If you've used Figma, which is a sort of UI sketching tool, it runs in your browser as a collaboration, but it's really fast. That's not written in JavaScript, that's written in Rust, and it runs in your browser. So WebAssembly is incredibly interesting and has a really good future. It itself is a standard, so it's probably here to stay as a relatively safe bet to get into if you really want to challenge yourself as a web developer. Cool. With that said, I've spoken a lot. Are there any questions before we get into doing? And if not, we will be coming around to answer questions and that sort of thing. Going to take that as another question. On screen up there, we have a link to a document very similar to the GitHub session for those who are there. If you walk through every single step on that, you will have a website posted by the end of the session. The website is written in Next.js, which is a framework for React. Next.js makes things more production ready. React by itself can be fairly clunky. Next.js sorts out some of that clunk for you, automatically hosts your site for you and those sort of things. But it's actually also using GitHub Actions, which allows you to push code from GitHub to a server automatically, as well as doing any other manual tasks automatically. And again, you'll be using Firebase. It's a good free utility. It's backed by Google. You've got other alternatives if you want to use them. But at least for today, we stick with those technologies and you'll have a pretty good time. Any questions, I'll be wandering around. Zach is also now an expert in this topic. So you can plug in for any questions as well. And we should be good to go. And free pizza will arrive at some point. Good. Cool. That's it.